Hello and welcome all again to the second session of MSP430 controller discussion. As mentioned, we could look over the details or learning procedure of any microcontroller or processor in two ways. One is looking through its architecture or block diagram model, and in continuation, we can also see the program and identify which microcontroller program it is written as. So here we can go with respect to MSP430 microcontroller second level discussion on programming model. The major contents that we will be finding with respect to the programming model is analyzing the instructions. What are in general the positions of any instruction? They go in a very simple manner, as any instruction format will be having a set of opcode and some set of operands. Opcode to any instruction will be 1. What we should do with the instruction is being decided with respect. What should we do with respect to the instruction will be decided by the opcode, and operand is what is that to be operated. Mostly the capacity of operand with respect to the instructions could be always started as 0. No operand could be there in any sort of instruction, but if we are treating it as an instruction, definitely opcode is mandatory. At least we'll be having opcode in the instruction, and count of opcodes in any instruction will always be only 1. With respect to operands, it could be 0, it could be 1, it could be sometimes 2, and sometimes based on the type of microcontroller design or type of the program we are making, it may also extend up to 3 or 4 operands with respect to any instruction format. In basic level, whenever we learn about programming, we propose 2 operands as a model size for any instruction format. So opcode along with some set of 2 operands, not always mandatory, a set of 2 operands could be treated as a model instruction format. So an example representation is given there as move R10, R11. The conditions are in general with respect to any other microcontroller. General things that happen we see is source will be on the right hand side and destination will be on the left hand side. But with respect to MSP430, the assembly language program is as represented in this given instruction format. Opcode, then source operand, then destination operand, left to right. This is a peculiar thing happening with respect to MSP430. Any other microcontroller assembly language format will be shown always in right to left. Source will be on the right side operand arrangement and destination will be on the left side operand arrangement. That could be a point of negligible arrangement for us, as we mostly work out on C programming model for embedded C programming model for our MSP430 operations. But as the architecture representation is given, we had to look over this. 2 major tools that are being used as a position of a programming model will be instruction set and addressing modes. How to obtain our operand for operation will be decided through addressing mode, and what to do after obtaining that operand will be decided in the instruction set. So as mentioned in the list, these are the various methods of obtaining our operands. So in general, you'll be having very common headings like immediate addressing mode. Wherever the data is found in the instruction itself, we treat it as immediate representation, or if we are giving or taking from any source register, we will be treating it as register addressing mode. Very basic and user-friendly addressing modes. In connection to memory operation, we can use indirect addressing mode or direct addressing mode, and sometimes indexed addressing modes. So in continuation, as we obtain some operand, what are the various operations that we can perform on that operand can be decided with some set of opcodes. So major headings that we can perform are major operations listed in the headings there that we can perform on any operand will be stated as transfer from one place to other place, perform some arithmetic operation, logical operation on that operand, or shift, rotate, or give some enhancements with the logical or boolean operations with the operands obtained, or we can shift the control of the program flow from one place to other place, which we consider it as conditional or unconditional branch control instructions. However, with respect to the programming model of MSP430, we pay more focus on programming through embedded C. So what are the factors we need to look over with respect to the programming of MSP430 using embedded C? We would like to first focus on the pin diagram of a MSP430 again. Now here we will be performing some port programming operations. So ports, how many ports we are sophisticatedly arranged with MSP430 are 2 ports. Each port is of 8-bit size. The name mentioned for first port is port 1. We can handle it through a complete set of port, or we can also handle the individual pins of the port. So port 2 is the next port provisioned with 8 bits IO pins. So again it also follows the same strategy of individual port handling or individual port pin handling. The facilities are given. Now, before moving into the programming facilities, if we are selecting any port, what are the minimum things we should know with respect to that port is, the very first statement that we add there is these ports are IO ports. So any port could be utilized as input port as well as it could be utilized as output port. We need to mention according to the application whether we are utilizing the port we have selected as individual port or bitwise operation port. Then we need to identify whether we are using it for input operation or output operation. To facilitate with this, we are having some provision with respect to the programming design. Each port will be having some arrangement like this internally. Now, 8 pins of port 1 which are aligned on the right side of the image shown, we can see that is facilitated only with the idea of showing all the port arrangement on one side. Each port pin with respect to, for example, port 1 is shown in a register arrangement. Like if we want to access P1.0, there is a position internally buffered to this pin. If we want to access P1.7, there is a position inside the device mentioned for buffering the operations. So what are the operations we have to do before selecting the port are as mentioned. There will be some support registers internally which will help the port to be addressed either as input or output. Some of the most familiar names that are being as mentioned is one of the register most prominently used is direction register. The direction register indicates whether we are using the port as input port or output port. The direction register indicates if we are using individual pin of the port, whether we are using that pin as input pin or output pin. How to identify this? As mentioned in the image here, we can see some representation shown with respect to P1.7. So P1.7 is first accessed with P1 DIR. P1 here stands as port 1 and DIR stands for the direction representation. So what is the first thing we have to show is as mentioned in the example there. Here P1 DIR is loaded with a number called 80H. Here 0x80 stands for the hexadecimal representation of the value. 8 here is analyzed as 1000 and continued as 000. This one will be with respect to port pin 7 of port 1. So we are first considering that let that pin be treated as output pin. How to show the port pin is utilized as output, keeping a 1 in this position. Now these two registers will make their activation based on the indication shown here. If I write 0 in this place, input register, input buffer operation will be activated. If we write 1 here, output buffer operation will be activated. Based on this arrangement, if we move on, what to do after this? Enabling of the port pin as output is mentioned. Now we can utilize this port pin for releasing a value. What are the maximum values we can release with respect to one port pin will be only 2. Either we can release a 0 or we can release a 1. Now based on the strategy we are using, if 0 is off and 1 is on, we will release the values called 1 for on and 0 for off. If it is used in active low condition, sometimes 0 is on and 1 is off. Based on the application we are suggesting, we will release either on or off situation. So this is the way of handling. Somewhere if we use a port pin to behave like a input pin, then we'll be making use of one of the register called REN, receive enable pin. In the coming arrangement, we can see that arrangement. Now to show that our port pin is being represented in high value, we are considering the arrangement is let, as just mentioned, we are using active high situation. Let 1 be high and 0 be for low. So if we release 1, it is on. If we release 0, it is off. So based on this, if we go with a simple strategic representation, what should I do if I connect one LED to a port pin? Example is suggested, like for example, we have connected an LED to P1.0 pin. So what is the purpose of connecting an LED to one of the port is, LED is an output device, so we need to glow that. So whichever pin that is connected to LED will be by default treated as output pin. So in the arrangement as mentioned, if I want to connect LED to P1.0, I should first make P1.0 as output pin. So what will be the final answer I should do with P1.0 is release a 1, binary 1 from P1.0 to glow the LED. But what is the previous step we should do is setting. Where to make this setting is in DIR register, direction register. And how it is going on? Looking over the first step, we will go to the direction register, then make P1 DIR as 1. So this is not giving value to the register, this is setting. What is the next step saying is LED will glow on with respect to the output that is provided from P1.0. So out indicates we can transfer the value, DIR indicates we are only setting the value. The condition is like this. If I release 0, LED is treated to be off. If I release 1, LED is treated to be on. So let us practice a simple application like interface an LED to P1.0 of the microcontroller and perform blinking in the sense toggling of that LED. So how to write the same steps in programming manner? In general, whenever we frame a program, never write the program. First analyze what are the things we require. So I have shown you the analysis first, then the question next. Now if we go in a order, let us create a program to interface an LED with P1.0 and frame a program that could operate in operating the LED through toggling operation or blink the LED through some on and off continuous operation. So the steps required is we need to connect the LED to P1.0, then P1.0 should release something that could glow the LED. For example, it should release 1 to glow the LED and 0 to off the LED. Before doing this output, we need to make a prior step called setting. P1 DIR is an arrangement that should be first to focus to show that we are first selecting P1.0 to behave like a output pin for us. So if we continue there, now we can see a simple program for our analysis. So in general, whenever we frame a C program, we will get back with the introduction of libraries. Generally, we might have practiced on stdio. These are the libraries with respect to MSP430. So whatever included library we need to have, we are going to invoke that library. A simple representation of library invoking is as mentioned. Hash include, either put that in arrow brackets or put that in double quotes, MSP430.h. Then the main function should be written opening through the braces. And these braces, before writing these, we can write the main in different formats as mentioned, void main int, void main void, only a main, or void main nothing. All formats are valid. Then once we open the braces of this main function, it is our next task is what are our requirements. So a line as mentioned in the program, line number 3 there, P1 DIR is equal to, that vertical line is proportionally equal to 0, 1. 0, 1 indicates we are making P1.0 as output pin. Then P1 DIR is used for setting. Why we used I may be a different task for us based on our requirement. Then we used I for this purpose, to make this situation exist for some period of time, like on and off. We need a count, so the count is being utilized by a loop operation here, considering it as for I can declare this I here also, no problem with this declaration. Int I is equal to 50,000. I should not be equal to 0. If I is not equal to 0, enter the loop, perform the operation, decrement the count of I by 1, again check the condition I is not equal to 0, enter the loop. Perform this loop operation until I becomes 0. What type of operation should it perform is, it should toggle. What is the meaning of this cap symbol on the instruction here is toggling the P1.0 pin. So if it is 1 already, then LED will glow. At the next clock or the next now count, it will be going it as LED is off, again on, again off, and it will be happening as until the count becomes 50,000 to 0. So I can give a rough answer like 25,000 times it should be on, 25,000 times it should be off. So we are saying as times. So if we want to show with respect to particular time, saying like I want this on for 1 second, off for 1 second. How to write with respect to time? The same bit, if you see, if it is the same program, if you see, when it is written with respect to time, is as mentioned. Additionally to that, we are giving some more enhancement to the example, like let not operate only on one LED, let us operate two LEDs. One of the LED is connected to P1.0, one of the LED is connected to P1.6. Now we want some patterns like both LEDs should be on and off simultaneously. Another pattern we would like to have is two LEDs should be operated as mentioned, and they should glow alternatively, saying like when it is on, this should be off, when it is off, this should be off. So how to frame a simple program? As mentioned, some of the common lines that go on are as given. Then we can see a new thing as represented here. P1.6 stands as the last but one pin of port 1. P1.0 stands as first pin of port 1. So they are being first activated using dir. Then in condition we say, here we have used another situation like a loop with some true arrangement, saying like when clock is going on, while 1, do this operation. Now as mentioned, if I want the delay with respect to time instead of count, what should I do is utilize some internal functions that are being declared in the library, saying like timer functions, time delay functions. The writing procedure of this time delay function is fixed. We have another way of writing the delay also. We can directly write delay some number, then also it will be valid. Here delay will be some sort of internal sub function written for generating delay program, considering it as 1000 milliseconds. The value that we show in the brackets will be milliseconds. If I write 500 here, the value will be treated as 0.5 seconds of second. If I write 2000, it will be treated as 2 seconds. So millisecond value is represented. So this program shows like first two LEDs will be on for 1 second delay, then two LEDs will be turned off for 1 second delay, and this will be a continuous operation while the clock is going. Now take the same program and represent it with, for the second case, they should be operated alternatively. This program highlights that. First line in common, second line in common, then make the setting. The only difference that we would like to show is both are on and off simultaneously. One line you could see in new here is same program. This is not going with the second case, first case itself. Instead of writing it for 2 times, we are using a toggle operation here. Toggle in the sense, if it is on, at the next instant it will become off. 41 will become 00, and 41 will become again 41 after a toggling operation. So only those pins which we have highlighted, only they will be operated. All other pins will not be in the scene there for us. So only this. One point to highlight here is, sometimes we need to make our controller in such a situation that no other thing should disturb us. So we are saying like watchdog timer, you don't come after every 32 milliseconds and come and disturb the CPU operation. This is a most negligible line when it is up to basic applications, but for high-end application interfacing, this line has its own importance. These are some codes that are used to surpass the watchdog timer or stop the watchdog timer. Anyhow, putting more concentration on the program, same program which we have written in early case for generating through delay, we are doing with a toggle operation. Right, that is the case. Now, glowing the LEDs alternatively, this is our task. So what we highlighted there is, we will glow P1.0 first, P1.6 as off. When we glow P1.6, P1.0 should be off. This should be the situation. As mentioned, both pins should be simultaneously activated. Then individual pin operation can be shown here. In this case, P1.0 is on, P1.6 is off. In the second case, P1.0 is off and P1.6 is on. And this can be performed using some delay operation. Slowly, we are improvising. One LED blinking, two LEDs blinking, then two LEDs going for alternate arrangements. These things could be still improvised. Before going for some more practice level, we can look over the practical thing that we are using. Why we mentioned two names like P1.6 and P1.0 for our operation is, we could look over this. P1.0 has an inbuilt LED arrangement with respect to the launch pad of MSP430. LED 2 of the launch pad is connected to P1.6. It is not a rule like we should use only P1.6 or P1.0. It is only a support, like helping for practicing, for learning purpose. Then in the same way, we will be having some switch arrangements also. P1.3, you can see the arrangement here. This is a push button arrangement which is connected here. Then we can see switch 1 is also arranged here. So either we can use this or we can use this. Mostly preferred will be P1.3 for our operations. So this is a represented launch pad which will be having some supply arrangement. Then it will be having some, these are all power manipulation section from where we connect a wire to the CPU of a computer and we dump our program into this chip here. So all are the connecting support peripherals. Now we can highlight, see this arrangement for clock generations. 25 megahertz clock arrangement will be provided from this section. And all other are jumper arrangements to help the microcontroller function in a proper way. Then this could be a top view arranged of individual pin multiplexed with each other. Mostly not so much to be highlighted right now. When we go with practice, we can see one of the major point we would like to put interest on is this version, which is having two ports, port 1 and port 2 in 8-bit format. So they are been having their own internal arrangements. LED is connected to P1.0. Here also P1.6 is connected to another LED. Colors are also been mentioned. If we use in practice, red LED means P1.0, green LED means P1.6. That will be the representation. Now, in continuation, we were going like this. Slowly, if we increase the count of LEDs, so far we worked on 2, then 1, then we shall see 8 LEDs if we operate what to do. The program now shows is glow all the LEDs at once, then alternatively glow the LEDs. Then third case is 4 LEDs are on and 4 LEDs are off. Then last case is all the LEDs are off. The condition is as mentioned, even as different patterns could be generated based on our requirement. The thing that makes importance here is this line, P1 DIR, make all pins of port 1 as output. This is a unique program that makes the utilization of all port pins of port 1 as mentioned. First case, all are on. Yes. Second case, alternatively. Then we can see the representation here. They are alternatively on and off. Third case, 4 are off and 4 are on. In the last case, all are off. Now, maybe it is easy to understand. Now if we put a condition like all this should happen in some condition, like if I say when a sensor is operated, then only the LED should glow. When a switch is operated, then only the LED should glow. In this situation, how to frame the same program in a different way? Now this is one of the line that stands in common. Now now this line could have made some sense here. P2 REN. What is that REN? We just spoke in earlier discussion saying like REN stands for receive enabling arrangements. So whichever pin we want to make as input, we are going to take it as input. So here P2 stands as 4 to 2 pin. Which pin of 4 to 2 we are using here? 1. So P2.0 is treated as input. What is that we are adding to the program is the same arrangement of multiple operation on LEDs should happen, but only on one condition, like whenever we press the switch, then only this should happen. The program is enhanced saying like if the switch is not pressed, then all LEDs should be off. If the switch is pressed, then the patterns should happen at a regular delay. What we call them as blinking of LEDs, dancing LEDs, pattern LEDs, array of LEDs. All such sort of programs can be done based on some delay programming. So each pattern should exist for a delay of 1 second, and they should automatically change their pattern whenever the switch is pressed. So how it is being operated here? If P2 in, what is P1 out here stands like send the data from P port 1. P2 in stands like read the data from port 2. Whatever you might read, along with that and also what should be activated? P2.0. If the input is from P2.0, whichever other pin might be receiving the input, we are not interested. We are interested only in P2.0. If it is reading something, then you can operate this. So if P2.0 has read, then glow the LEDs all at once, then alternatively blink them, then blink them in a given pattern as 4 on and 4 off. Repeat this operation until the switch is in a pressed condition. Once the switch is off or some sensor in the place of switch is removed, then kindly switch off the LEDs in the given arrangement. This is the pattern. One line that I could neglect in this program could be this. We don't need this delay. Once it is off, it is totally off. It is only for a learning purpose saying like we require some delay representations. We will say all are off. Suddenly when switch is again pressed, the control will be transferred into the above condition, changing from one pattern to another pattern. Slowly the programming level is getting increased. We are saying from one LED, blinking the LED, then 2 LEDs, on and off of the LEDs, either simultaneously or alternatively, then some set of LEDs, making some pattern of LED operations, then working on some conditional inputs, like if the input occurs, then only the output should be generated. Multiple such programs could be performed in practice if we go with MSP430 programming model using embedded C. Now at this part, with this basic discussion of programming model, we are going to end the discussion for programming model of MSP430 with respect to the syllabus pattern. We have plenty full of applications that we can run over that. Now thank you for considering this session.